Welcome to Who Shaves the Barber, a weekly podcast where we explore paradoxes, thought experiments, and other pointless problems. I'm William Nava. Today, my guest is Professor Timothy Williamson. So, Tim, welcome to the show.
Thank you.
So, just to quickly introduce people to who you are. So you're a professor at the University of Oxford.
Yes.
And your work has primarily focused on epistemology, logic, metaphysics. A couple of your books, so you've written a book called Knowledge and Its Limits, Philosophy of Philosophy, Modal Logic as Metaphysics, and Vagueness, which we'll mostly be talking about today. Now, you also have your most recent book is called Tetralogue, I'm Right, You're Wrong. And before we get started on Vagueness, I wanted to ask you to tell me just the quick pitch of that book, because that's somewhat of a different type of project than what you've done before.
Yeah, well, so one way it's different is that it's written in dialogue form. It's not at all technical. It's meant to be something that any intelligent person can read, and it's about the way in which issues to do with truth and falsity arise in ordinary life, and the kind of temptations there are to think that these are all relative, that somehow things are just true for me and false for you, or vice versa, and that there's no bottom line as to which of us is right and which of us is wrong. And I think that kind of relativist way of thinking is fundamentally very confused, and I've used the dialogue to try to bring out what I thought was confused about it.
Okay, so it's a fictional kind of conversation, which
Yes.
you hope kind of brings out some of the absurdity in the relativistic outlook.
Yeah, and quite a few other issues as well, issues about skepticism and morality and so on. But yes, it's done in the form of a dialogue between four characters who meet on a train and then somehow get drawn into philosophical questions.
Sounds interesting. Okay, so let me now dive into the topic. So I want to talk to you about vagueness and the sorites paradox. I've been interested in the sorites paradox for a while, and that's how I first heard of you. You are very significant in this area in the sense that there's a particular solution to the sorites paradox, which to most people, when they first hear it, sounds incredibly counterintuitive. And you are largely responsible for making a strong enough case for that apparently counterintuitive solution that it's now one of the sort of main contenders in the discussion. And that's, of course, the epistemicist solution. So let's just start from the beginning. Can you give a quick overview of what the sorites paradox is?
Right. So the sorites paradox, it's called that because it's derived. The name is derived from the ancient Greek word for a heap, and this was a paradox that was known to the ancient Greeks. I mean, one quick way of putting it is that if you imagine a heap of grains of sand or corn or whatever it is, and then you imagine just say one grain being taken off the top, and then you ask the question, do we still have a heap? The obvious answer is yes. And so we seem to be signing on to the principle that if you take just one grain away from a heap, the result is still a heap. But of course, if you think about it, a heap only contains finitely many grains, maybe 10,000 or whatever it is. And so if you keep taking grains away, eventually you're left with just two grains and then one and then zero. But we've got this principle that every time when you take one grain away, you still get left with a heap. And so we seem to be committed to saying that there's a heap even when there are only two grains, even when there's only one, even when there are none, which is, of course, is an absurd result. And then we might think, oh, well, maybe that principle that if you, as it were, a heap minus one grain is still a heap, maybe that's wrong. So, but if it's wrong, then just by standard reasoning, there must be a particular number such that you have a heap when you had that number of grains, and then you took one away and you no longer had a heap. And it seems crazy to suggest that just one grain can be the difference between having a heap and not having a heap. I mean, in ancient Greece, the way they like to put this paradox was in terms of just a series of questions. So they start with, do 10,000 grains make a heap? Yes. Do 9,999 grains make a heap? Yes. And the idea was that if you said yes to one of these questions, and then you refused to say yes to the next question, there was something crazy going on, because you were making such a huge deal about a single grain, which oughtn't to be able to make such a difference between a heap and no heap. And I mean, this may sound a slightly sort of trivial kind of problem, but it's really turned out to be very, very deep, because it has to do with the phenomenon of vagueness. For example, the word or concept heap is vague, because when you learn the word heap, you're just shown some examples of heaps, and you get the idea, but we don't have any specific definition of how many grains are needed to make a heap. So there's something vague there. It's not precisely defined, and it seems that with most of the concepts that we use in our lives, that they're vague in a similar way, that we can find cases where it's just unclear whether to apply them or not, and we can typically devise sorites paradox or paradoxes like the sorites for them. I mean, for example, the ancient Greeks gave examples involving terms like rich and poor or tall and short. I mean, they knew that it was a very, very general problem. And the underlying issue is just how can we reason correctly with vague words or vague concepts so that we don't end up contradicting ourselves. And since most of the terms that we use are vague, and in principle, this is a question that arises for most of our ordinary thinking. I mean, of course, we don't normally press it so far to get to a contradiction like that. But if the ways that we're thinking with vague terms have these contradictions built into them, then it seems like we ought to be able to do something about it and try to find a consistent way of thinking with vague language and thought. Right.
Yeah. I mean, one thing that's really striking about the sorites paradox is at first it seems sort of trivial, and you think, oh, it's about heaps and this, but really it doesn't take much thought to realize that really almost all of our concepts are vague in this way. Almost all of our concepts, you can find borderline cases where it's sort of not clear whether it applies or it doesn't apply. So I want to, before asking you the next question, I want to sort of establish a couple of key terms that I imagine will come up during the conversation. So the principle that you said, that if you have a heap and then you remove 1 grain of sand, it's still a heap. That general principle, as it applies to any vague predicate, people often refer to as tolerance or the tolerance principle.
Right.
And then there's also cutoffs, right? So the idea that if there were one specific grain of sand that is where the switch happens, that would be the cutoff point. I wanted to just kind of establish those. Now, my next question is, sometimes when I've talked to people about the sorites paradox, I think the most common response I get from people who haven't thought about it a lot or who are not particularly interested, let's say, in logic or something, is, well, of course that language is vague. And in a sense, you're asking too much of natural language. You're working within some kind of logical framework, which assumes precise definitions. That's not how natural language works. And so there's really nothing so mysterious here. There's nothing to really solve. You're just applying this formal apparatus to a natural language that is not formal, and you shouldn't expect this to work out well. What's the big deal?
Yeah. So, well, I think one thing to to say is that the ancient Greeks, they realized there was a paradox here, and that was not because they were using some kind of formal apparatus. I mean, they didn't have an agreed formal apparatus that they could just bring to bear and sort of wind the handle to see what it did. They were thinking in much more ordinary, intuitive terms about this. So it's not just an artifact of formal systems that we can now apply to it. I mean, of course, like any deep theoretical question, it's one that you can walk away from if you're not interested. I mean, that applies just as much, to problems, in physics about, special relativity theory or quantum mechanics or whatever. If you don't care about those problems, you're not forced to think about them. You can just look the other way, and that's true with these sorites paradoxes as well. But if you have a bit more curiosity about these issues and you want to find out what's going wrong, what you want to do is to find some way of thinking and reasoning about these kind of cases which arise all over the place, which doesn't get us into trouble. And it's not enough just to say, well, we can relax and sort of not think about these things, because in any kind of serious theoretical inquiry, what we're doing is we're taking some basic principles and ways of investigating the world and pushing them really hard to see where they lead. And and if we find out that where they lead is contradicting ourselves, then something has gone wrong. And it's a pretty reasonable question to ask. Well, what is it that's gone wrong? And and I think that people who say, well, language is vague, and so that's all we need to know, and just walk away from it, they're basically not curious to understand why our ways of thinking are getting us into trouble. But a lot of philosophers would like to understand that better, and I think it's a natural thing to understand that, want to understand it. Just as with any kind of method that you might use in the sciences, if there are areas where it's giving you disastrous results, you want to understand what's wrong with that way of doing things.
Right. Yeah, that makes sense. And assuming that you're interested in some kind of account of language, and that you assume that there's some coherence to language, then essentially the sorites paradox puts you in a position where you have to essentially make some choices, right? Accept that there are cutoffs, or deny some kind of principle, show some kind of area where the argument goes wrong. So I think that makes sense. So I think where this gets very interesting for me is in looking at the various different kinds of solutions. And I'm interested in discussing some of the more popular ones and to hear what you think is wrong with them. Before going to those, can you give just a quick introduction to your favorite solution, the epistemicist solution?
Yeah. So epistemicism is the idea that what's happening in these paradoxes is that there are cutoff points for these vague terms, but they're ones which we're just unable to locate. So there is an exact point in that process when you went from having a heap to not having a heap, but we just don't know when that happened, and so because we expect to be able to know whether we've got a heap or not, we get confused and start coming up with the idea that there can't be a cutoff point because we can't find one. But there's no guarantee that that everything in the world is something that we can recognize, and so the idea that there's an unrecognizable cutoff point is really not so strange. And I mean, one important aspect of this solution is that it enables us to use what's often called classical logic, standard logic, which is based on the idea that propositions are statements are either true or false and not both, and that's something which has been rejected by many people who've tried to understand what's happening in the sorites paradoxes. They've thought that we would have to change our logic, that we would have to think that there are somehow gaps between truth and falsity, whereas the statement is neither true nor false, or maybe what gluts, where a statement is both true and false. And for example, in some cases, they've gone to the idea that it's not an on-off kind of dichotomy between truth and falsity, but some sort of continuum of degrees of truth, which just vary gradually. And these alternatives, they all have quite serious costs in telling us that there are lots of quite intuitive ways of reasoning which are basically illegitimate for almost all of our thinking because they don't work for vague concepts. Whereas on the kind of solution that I'm giving, these standard ways of reasoning are in fact perfectly correct. It's just that we have to recognize our own limitations, that there are cutoff points that we can't identify.
Yeah, it seems to me, based on the reading I've done about this, that most solutions, so even putting aside the obvious costs of sacrificing some basic principles of classical logic, it seems to me that most solutions either they end up not really being coherent because they can't get around higher order vagueness, and we'll sort of get to what that is, or in some way they end up implicitly accepting that there is a cutoff, at which point either we know where that cutoff is, or that solution is actually a kind of epistemicism. That's kind of been my experience of trying to look at some of these solutions. Let's talk about just a couple of the more popular ones. What is, I think one of the more popular ones is supervaluationism. Can you give a quick explanation of what that solution is?
So supervaluationism, it's based on the idea that in some way we haven't fully specified meanings for our terms, and when they're vague, and that there are many different meanings, all of which are consistent with the way that we use them, and which, for example, many different meanings for the word heap, which would put the cutoff point between heap and no heap at different places. I mean, some might say that you need at least 10 grains, some might say that you need at least 15, and so on. And I mean, the way that supervaluationists typically think, the only time when you have a genuinely true statement is when you have a statement which is true on all the meanings that are consistent with the way that we're using the word. So this would, for example, when you say there's a heap, for that to be genuinely true, or what they would call super true, it's got to be that on all the ways of setting a cutoff point for heap that are consistent with the ways that we use the term, it's got to count as being a heap. And then super falsity is the sort of opposite of that. That would be that on all the ways consistent with how we use the word heap, that you could set a cutoff point, it's going to be false that we have a heap. And then there will be a sort of an intermediate zone of what they would call borderline cases, which are neither super true nor super false. And that would be because, if, for example, if there were just 12 grains, then it would be, if you set the cutoff point at 10, then it could be true that there's a heap. But if you set the cutoff point at 15, it would be false that there's a heap. And so it's neither super true nor super false that there's a heap. And then so that for them is just a gap between what's genuinely true and what's genuinely false. It's neither. The way we use the term just doesn't determine a meaning.
So, for example, 1 grain of sand is a heap would be super false. There is no sort of reasonable precisification of the term in which that would come out true. Maybe 20 grains of sand is a heap is probably a borderline case in there somewhere, and 200 grains of sand is a heap is super true. Pretty much any version of heap that you like is going to say that that's going to be true.
Yeah, right. I mean, of course, just to interject. Of course, we've got to understand that these are kind of heaped up in the right way. I mean, if we just had 200 grains of sand, in a line, that wouldn't be a heap. But I think that's understood. Yeah.
Yes, assuming the appropriate shape and other parameters. So what's the easiest way of understanding what the problem is for supervaluationism?
Well, I think so. A simple way of putting it is that it doesn't respect the logic of the notions of truth and falsity. So, for example, a very basic principle about truth and falsity, which was already known to Aristotle, is that, for example, if it's raining, then it's true that it's raining, and if it's not raining, then it's false that it's raining, and vice versa. And when you work through the supervaluationist view, you find out that it doesn't actually respect those principles. That, for example, it's a heap. If it's a heap, then it's true that it's a heap. Doesn't come out true on the supervaluationist understanding, but basically because there will be some ways of understanding heap where it's true, which put the boundary in such a way that what we've got is a heap, but it's still not super true that it's a heap because there are other ways that don't do that, and so. So, as it were, the first strike against supervaluationism is that it doesn't respect these principles, and then the second point is that actually we could define a notion of truth within the supervaluationist framework that did respect these principles, but that's not what they think of as genuine truth, even though it behaves more like the way genuine truth is supposed to behave. And the kind of defense which supervaluations initially give for having this somewhat weird notion of truth, which doesn't behave the way truth is supposed to behave, is that, well, at least what they're doing is kind of making the idea of truth more precise for these vague terms, because they're looking at all the different ways of setting a cutoff point rather than just arbitrarily choosing one. And I mean, that sounds okay until you realize that there is exactly the kind of problem that you mentioned, the problem of higher order vagueness, and that has to do with sort of borderline cases of borderline cases, because the way that a kind of naive version of supervaluationism works is that you would have a sharp line between the cases where it's super true that there's a heap and the cases which are borderline, with neither super true nor super false, and then another sharp line between the borderline zone and the cases where it's just super false that it's a heap. But when you think about it, you realize that that's totally implausible, because just as we can't set a sharp boundary, I mean, we can't identify a sharp boundary between the true cases and the false cases, we can't identify a sharp boundary between the super true cases and the borderline cases. I mean, if you like, between the clear cases and the unclear cases. It's not clear where we lose clarity, and so the supervaluationists, recognizing that, have been forced to introduce a much more complicated structure that allows for borderline cases and borderline cases. But then the effect of that is that their notion of supertruth loses the one advantage that it had over the kind of rival notion, which behaved much more like the way truth is supposed to behave, which is that, I mean, initially it seemed like an advantage that it was more precise, but now, when we think it through, we realize that it shouldn't be precise, because we don't have these, we can't identify these higher order boundaries, just as we can't identify the first order boundary between heap and no heap. And so the way in which supervaluationism is deviating from ordinary ways of thinking about truth is in the end not actually getting any real advantage. So it's complicating things in a way for no benefit from a logical point of view. Right.
So it just to kind of maybe reiterate it. It seems so. Assuming, let's say, that 15 is a borderline case and 3 is a clear, a super true case, there must be some first borderline case, right?
Yes.
And so that now has reintroduced a cutoff, where before we had one cutoff between applies and doesn't apply. Now we have two cutoffs, right? Between super true and borderline, and then between borderline and super false. And now we want to explain away those two cutoffs. You're going to have to introduce a kind of borderline of when between the super true and the borderline, a kind of meta level borderline region. And now and I guess presumably that can be iterated.
Yes, and so times as you like. Yeah.
Right, and now you've got a situation where you've got this sort of regress of expanding cutoffs, and so and sort of said, as you said, we're losing some of the actual appeal of the solution.
Yes, I mean, just to change the example for a bit, and put basically the same point in other terms. So, I mean, suppose that that we have a continuum of colors, let's say between red and orange. So at one end we've got something that's clearly red. At the other end we've got something that's clearly orange. And then at the first level, the challenge would be to say, well, where's the line between the red shades and the non-red shades on this continuum? And then we can't identify a line. There's going to be a region of uncertainty, and so we say there's a borderline zone. And then at the second stage, we've got this division into the colors, the shades of color which are clearly red. At the other end, the ones which are clearly not red, and then in the middle, the ones which are neither clearly red nor clearly not red. But then if somebody asks us, okay, so where's the line between, let's say, the clearly red ones and the ones which are neither clearly red nor clearly not red, we're just as flummoxed by that as by the original question, where's the line between red and not red? We just have to say, look, we don't know, it's roughly there, but there's no one place where I can locate it with any confidence at all. And then we start having to put borderline zones of borderline zones, and as you say, that whole process can just be repeated as many times as you like. So the borderline cases of borderline cases of borderline cases, and so on.
Now, I don't want to get too sort of complicated here, but it seems to me that there's one way in which there's two types of sorites. There's a sort of concrete sorites and continuous sorites, right? So in the grains of sand one, the amount by which we change is 1 grain of sand. And that's sort of our kind of limit. And whereas maybe a difference in the way a color appears could be seen as continuous, like you can keep breaking it down as much as you like. It seems like maybe in concrete sorites, like the one with the grains of sand, would there be a limit to how many times you can iterate the higher order vagueness?
Well, I mean, if there are only finitely many positions in the series, then although one can, keep iterating the words borderline and borderline, borderline, and so on, then we're not going to, if we thought of them as giving different, as having corresponding to specific patches of this series, then there are only finitely many options, so we couldn't get different options for each iteration. But that's if you think in terms of just classifying all the shades, one way or another, and but of course, all of those classifications themselves have zones of unclarity, and so that as we keep repeating these terms like clearly or not clearly or whatever, I mean, those may go on making some kind of difference in terms of our understanding, even if they can't correspond to, as with infinitely many different places where we can put a line, because there are only finitely places on the series. I mean, you're absolutely right that in principle there's a very significant mathematical difference between the discrete cases where we only have some finitely many positions and the continuous ones where we have infinitely many. But in practice with these paradoxes, the difference between the discrete and the continuous cases, it doesn't really matter so much, because the crucial thing is just to get down to as it were, a difference which is so small that it seems trivial, and then you can do that in both the continuous and the discrete case, and then that's what gets the paradox going. So as it were, the mathematics of infinity don't really matter much for these paradoxes in the end.
So there are a number of other solutions that are popular, and I don't, there are so many. I only want to go over a couple of them. Another very popular is the three valued, and even though that's a very common one, I don't want to cover it because it seems to me like it suffers from very much the same problem we've been discussing, right? So three valued says sometimes it applies, sometimes it doesn't apply, and sometimes it neither applies nor doesn't, and so you have the same borderline region and borderline of borderline regions. I think maybe one we should say something about, although I think the problem with it, at least as far as I can tell, is similar, is the degrees of truth solution. Can you say something about that?
Yeah. So the degrees of truth is the idea that that some statements may be truer than others without being absolutely true, and for example, that if you just think about a day when it goes from being bright day to being pitch dark as the sun sets, then you could think of the statement it's light or something like that as going from being more or less perfectly true to more or less perfectly false by a completely continuous gradation of steps, or maybe you could think of it as millions of tiny steps, and each of those would correspond to a different degree of truth. So actually the idea of degrees of truth, it can be developed within different theoretical settings. So you can actually have a version of it that works within the supervaluationist approach, and where degrees of truth behave quite like probabilities. But I think the most famous approach based on degrees of truth, which is interesting because it's different from supervaluationism, is what's often known as fuzzy logic, where the idea is it's not simply that there are degrees of truth, but that whereas in classical logic you have two valued truth tables so that you can work out the truth value of a complex statement such as it's not raining, or it's raining and it's snowing, or it's raining or it's snowing, in terms of the binary truth values of their components, raining and snowing. And in the case of fuzzy logic, you have something like that, except that it's done with infinitely many valued truth tables, where you can work out the degree of truth of a complex statement in terms of the degrees of truth of its components. And that actually produces a second lot of problems for the fuzzy logic, which don't arise, in fact, for supervaluationism, because these infinitely many valued truth tables have very, very odd results. So, for example, one effect that they have is that in a borderline case, supposing we have normally they think of these degrees as like running from 0, which would be perfect falsity, to 1, which would be perfect truth, and then 0.5 or half would be sort of perfectly balanced between truth and falsity. And the way these tables work in fuzzy logic is that in a borderline case, it's half where it's half true, half false that it's a heap. It becomes half true to say it is a heap and it isn't. In other words, to contradict yourself. And maybe that initially doesn't sound too bad, but it sounds. I mean, a way of bringing out what's so weird about it would be that supposing we have two heaps which are exact replicas of each other, the same number of grains arranged in exactly the same way, and suppose that we every time we take a grain from one, we take a grain from the corresponding position in the other. So this is completely symmetrical between the two heaps. Then it seems like one thing would be completely false to say about this, which is the one on the left is a heap and the one on the right is not a heap, because they're perfectly symmetrical. So if one is a heap, then so is the other. I mean, just as much. But the fuzzy logic approach implies that halfway through this process, when it's sort of half true that it's a heap, it will be half true that the one on the right is a heap and the one on the left is not a heap. And that seems exactly the wrong result, because we want it to be perfectly false that the one on the left is a heap and the one on the right is not a heap, because there's no difference between them in any way that's relevant to whether they count as a heap or not. And so it should just be totally false, and we can simply rule out that statement. And so the fuzzy logic approach gives these very counterintuitive results when you apply it to complex sentences. And I think the moral of that is that degrees of truth just don't feed into truth tables in the way that classical binary truth or falsity truth values do. And so I think there's an additional cost to fuzzy logic, which makes it much worse, in fact, than supervaluationism as an approach, even though it's quite, it's one of the more popular approaches in the sort of a lot of the descriptions outside philosophy of this problem.
It seems to me that aside from everything you just explained, tell me if I'm wrong, it seems to me that the fuzzy approach is also going to fall into the higher order problem.
Yes,
because,
that problem as well, yeah.
Essentially because there's going to be cases where the degree of truth is, let's say, 0. And there must be then some first case in which the degree of truth is whatever positive number you like, 0.0001 or whatever it is. And so now, even creating this continuous spectrum of degrees of truth, you still are sort of unable to avoid a cutoff because of the higher order vagueness problem.
Yes, that's right. And even if we were to say, well, in real life, we never get perfect truth or never get perfect falsity, we could give a similar argument which had to do with degree of truth a half, because certainly in real life, if we're thinking in this fuzzy logical way, we're going to be able to go from cases where it's more true than false that it's a heap to cases where it's more false than true that there's a heap, and so we're going from cases where the degree of truth is above a half to cases where it's below a half, and in a continuous process, and that means that there must be some exact point at which it's exactly a half, and yet we have absolutely no idea where that exact point is. So even if we think we can't occupy the extreme 0 and 1 positions, we've still got the same problem just by thinking about a half rather than them.
Right. Now, another type of solution, less popular, but it has been considered, is nihilism. And this, as far as I can tell, comes in a couple of different forms. One of those is the rather extreme view that these predicates, in fact, just are never true. They never apply. Can you say something about that view?
Yeah. So this is a view which the New York philosopher Peter Unger once defended. I mean, he wrote, for example, an article whose title was "I Do Not Exist," which was arguing for his own non-existence, on the grounds, in effect, that even the word "I" it has a kind of vagueness about it because of this kind of borderline. I mean, you could have a sorites for a person just by subtracting one atom at a time from them, and so of course. If the view is right, then this article had no author, but also there's going to be no such thing as this article because the term article is itself vague, but and if you subtract one letter at a time from an article, then you stop having an article, and then the view is often put by saying, well, these words just have no application, but the word itself is vague. It's vague when you have a word and when you don't have a word, and so on this view there aren't any words either, and there aren't any thoughts. There's nothing to be vague, and so it ends up as pretty much total intellectual suicide. I mean, there's pretty much nothing that you could say on these views, and so if one is so inclined, one can just completely despair and give up philosophy and think that these things are completely insoluble. And of course, this wouldn't just actually be a problem for philosophy, because if these views are right, then nothing that physicists say would be true, because none of their terms apply to anything, and in fact there aren't any physicists, and because there are no more physicists, but by the same argument that Unger used in arguing that he didn't exist, and so every form of inquiry or indeed of language would just be completely bankrupt on this view. So it is saying really that any kind of thought or talk, well, there isn't. It would be a failure if there were any, but there can't be any. So I mean, that seems like a pretty dark place to be in.
Yeah, I've tried to think about how to defend it by saying, well, maybe a person, the way we normally think of it, doesn't exist, but a more sort of fuzzy type of thing does exist. But really, any way you try to describe it, any alternative you try to give, you can apply the same paradox to. So,
right.
Really,
yes. Fuzzy is itself a fuzzy term, so there can't be any fuzzy things either.
Yeah. There's another version that I've heard of this, which is not exactly that the terms never apply, but rather something like the sorites sentences, when you try to apply a vague term, it's really not a proposition. And so the idea is propositional logic. This is somewhat related to something I said at the beginning of our conversation. Propositional logic, we shouldn't expect propositional logic to apply to our vague terms, but nonetheless, our vague terms do have meaning. The meaning is given by essentially degrees of satisfaction profiles, but because those are sort of, again, kind of fuzzy, we shouldn't expect propositional logic to apply to them in the way that we expect it to apply to perfectly precise statements. Do you think there's anything to taking this route?
Well, I mean, it seems a somewhat undeveloped view, because if classical logic doesn't apply, then the question is, well, what sort of logic does apply, or is it a view on which no logic applies? On which Donald Trump is just as logical, as the greatest logician in the world. That seems, again, a very kind of dark view to come to. If the idea is, well, basically there are no logical principles which are valid, then and this, I think you end up with just there's no standard that you can apply to reasoning, and so there's no distinction between someone who's being consistent and someone who's being inconsistent, and that again seems like if a view as extreme as that were the case, then it's very hard to see what kind of reasonable thought would be possible.
There's one more view I want you to address before we kind of dive into epistemicism, and that is the contextualist view. As far as I can tell, there's quite a number of different sort of variations on the contextualist view. I'm somewhat familiar with Diana Raffman's. Can you kind of are you familiar with Diana Raffman's? Yeah. Can you give a kind of summary of it and what you think is the problem with that?
Yeah. So, contextualism, the basic idea of it is that what words refer to depends on the context in which they're used. And I mean, this is something that we're pretty familiar with. I mean, for example, we were talking about the word I, and the word I refers to you when you use it, and it refers to me when I use it, so that its reference depends on who's using it. And the word tall, it has one reference, in a context where we're talking about basketball players, and another reference in a context where we're talking about children or something like that. Because the comparison class is different, and contextualist views of vagueness say that the reference of vague terms changes as the context changes, and on views like Raffman, one thing that happens is that as you go along the sorites series, the reference of these terms is changing all the time. So it's very elusive, because if you try to pin it down, the very act of pinning it down try to pin down where the cutoff is. The very words in which you pin it down can change the context. I think probably the general consensus amongst people who work on vagueness is that yes, vague terms typically are context dependent, but no, the context dependence by itself doesn't explain everything. Because, for example, I mean, there are lots of vague words. There are lots of context-dependent words where the context dependence doesn't produce any kind of mystery, as with I and so on. If we're not talking about a specific sorites series, but we just ask a general question like how many grains make a heap. Where's the cutoff for grain or for heap, or maybe where was the cutoff for heap as we were using it 5 minutes ago or whatever. It doesn't seem that the context dependence is enough to explain the difficulty of answering these questions, because we have ways of handling context dependence that allow us to talk about context dependent terms and their reference and not get tangled up in the context dependence. So, for example, there were theorists like the late Delia Graf Farah who had a view on which actually a more sophisticated version of something like context dependence was involved, but she was very conscious that you couldn't do all the explanatory work with that alone, that you needed some kind of additional element to explain the block to actually locating a cutoff point in some more sophisticated way than just going along the sorites series and sort of waiting until you got to it.
Right. So in a way, if the problem were really context dependence, there's a way in which we should be able to fix the context, and yet the paradox will still arise. Would you say that that's roughly true?
Yes. Right.
Okay, so let's talk now about epistemicism. So epistemicism says, there actually are these cutoffs. We just can't know exactly where they are. Immediately, that seems counterintuitive, because I think part of the idea is these terms, their meaning actually is vague. And so how could it be that... I think when people hear this, they think of something kind of magical, right? Like we use a term that is supposed to be vague, and yet somehow this cutoff has appeared. How could this be? Can you give your sort of, you have an account that kind of explains this, that involves inexact knowledge and a margin of error. Can you give a sort of quick summary of it?
So one thing is, I think that these terms are genuinely vague, but the vagueness does not consist in they're not having sharp cutoff points. It consists in the unknowability of where those cutoff points come. And I think that just from the point of view of people's intuitions, as they're called, and so what is very vivid to anybody who uses a vague term in these cases is that they can't locate a cutoff point. But I think when we start getting to explanations for why they can't locate a cutoff point, then what we're doing is some kind of more speculative theorizing. It's not the kind of thing that we just immediately know what is preventing us from locating the cutoff point. And that's the point at which, as it were, the common sense tells us that we don't know where the cutoff point is. I mean, that's kind of obvious, but in order to explain why it is that we can't know that, we can't just rely on common sense. We have to do some kind of philosophical and linguistic theorizing, and so of course it's easy just to say, well, there is one, but we don't know where it is. One thing that I've tried to do is to argue that, on quite general grounds from the theory of knowledge, that we would expect this kind of unknowability to arise. And my account of why that's the case draws on this general idea of inexact knowledge. Inexact knowledge is a broader phenomenon than vagueness. I mean, it concerns all sorts of ways in which there are obstacles to knowing things that mean that we can't set an exact point. We can't know where it is, and so the kind of thing that I would take as an example of this is right now I'm in a room and I can't tell just by looking exactly how many millimeters high the ceiling of this room is. And I mean, I can make I know, let's say it's more than 100 millimeters high. I can see that it's not a trillion millimeters high, but in between there's a large area where I just don't know, and so I can't locate the exact number just by looking. And even if I were to stare, and reflect as hard as I could, I would not be able to work out the height in millimeters. And now that itself isn't an example of vagueness, because of course if we were to bring in some kind of measuring instrument, we could work out exactly what the height of these things was in millimeters. But in the case of vagueness, I think one thing that's similar but a little bit different is that the source of the problem has to do with the meanings of words, but not because it's impossible for these meanings to have a cutoff point, but because there's something a bit unstable about the meaning, so that which prevents us from knowing, in the sense that if I make a judgment, let's say that in some borderline case, that let's say between red and orange, if I were to judge, well, that's red, my judgment is not super sensitive to every detail of the way red is used, all of which contributes to the meaning of the word red. So I might make the very same judgment in a slightly different situation, where the word red was shifted in its meaning just a little bit, so that it no longer applied to that case. And so that my application of the word red, it's not perfectly sensitive to the factors that determine what the boundaries of red are, and therefore because I can't, as it were, calibrate my judgment perfectly to those factors. I'm just not reliable in the zone where the boundary comes at one place, but if people had used the word red even very, very slightly differently, it would have come in a different place. And that's because I'm so unreliable in applying the term within that kind of boundary. I'm not really leaving a margin for error, and therefore I don't count as knowing. And so the idea is that, on the basis of those general kind of considerations drawn from the theory of knowledge, but applied in particular to issues about the instability of the meaning of vague terms, we can predict that we're not going to be able to know where the boundaries come, even on the assumption that they have these sharp boundaries. And therefore, the fact that we can't locate these boundaries is not good evidence that they don't exist, because that's exactly what we'd expect, even if they did exist.
Now, I think that something that kind of becomes important here is an account of meaning, right? Because part of what you're saying is that there are factors that determine the meaning of the word red, and part of that meaning is going to involve the location of a cutoff. We are not sensitive to those factors well enough to actually know where it is, but it is part of the meaning of the word. And so I guess my next question is, what are those factors? What is it that determines the meaning of the word, and that does it in such a way that actually there turns out to be a cutoff as part of the meaning?
Yeah. So the kind of factors, a lot of it just has to do with the way in which the word red is used, what we apply it to, and what we refuse to apply it to, which of course varies over time. It varies from one individual to another, but all of that feeds into the meaning of the word read as a word that we all share, in the English language, and then roughly the picture it is that when enough of those factors are favorable, then the word read will be applied, will be determined to apply in a given case, and if there's not enough to determine that it applies, then that determines that it doesn't apply, so that it's bound to apply it or not apply in every case. So that's where it's a kind of really just a knock-on of basic logical facts that it either applies or doesn't apply, and that and therefore it's either true or false of these cases. But the facts which determine which it is are which determine what the word is going to mean. They're facts about how we use the word, and they can also be facts about the world out there, about wavelength of light and so on, and that becomes very important when we're talking about natural kinds. So that, for example, if we're talking about using the word gold, it's even if lots of us are suckered by fool's gold, so that we apply the word gold to it, we might simply be wrong because it's just got the wrong chemical structure to be gold.
Right. So essentially, it sounds like you're saying how we use words determines their meaning. There are other factors, such as the actual state of the world, so that we can so that even mass use can be mistaken. Yes. But nonetheless, it is in fact how we use words that gives them their meaning.
Yes.
So, okay, and so essentially, I think the picture that you're presenting is something like there are many different factors to how we use words, and they may be constantly changing all the time in very small ways, in ways that if you sort of take a complicated aggregate, it's not going to be as simple as just the average of times that people said this word in this situation. There would be a lot of parameters involved, but there's a kind of aggregate picture that comes from that, and it establishes a cutoff. And then as those parameters sort of change in small ways, the cutoff may change in small ways. And since we're not sensitive or even aware to what all of these parameters are, we're not ever going to know exactly where the cutoff is at any given moment, though we generally know in which cases to apply the term. So is that roughly what you say your picture?
Yeah.
So there's it seems like you can create a sorites out of knowing and not knowing.
Yes.
Right. And so you could say something like, I don't know if this predicate, I don't know if this thing is read because it's close enough to the cutoff, to wherever the cutoff might be, that I don't know if it actually applies. And if it's only this much further away, then I still don't know. Therefore, if the thing looks green, I don't know if it's red or not. How do you deal with that sort of revenge problem?
Well, I'm not sure that it's really a revenge. I mean, I agree that there are sorites paradoxes for no, that there are cases where there's a kind of continuum between knowing, with no clear cases of knowing at one end and clear cases of not knowing at the other, and cases which we don't know how to classify in the middle. And so what I'd say about that is what I would say about other sorites paradoxes. And in this case, what it means is that we don't always know where the boundary comes between knowing and not knowing. And one implication of that, as I work these problems through, is that there are going to be cases where you can know that something holds, but not know that you know it, and maybe not even be in a position to know that you know it. I mean, so that even if you think about it, you still can't know that you know it, but in fact you do know it.
Right. Okay. So that there will be cutoffs between when you know and you don't know, but you in fact don't know
Yes, that's
where
right.
where the cutoff for that is. Now it sounds like
I mean, these are what I guess Donald Rumsfeld called unknowns.
right, what you don't know that you don't know.
Yeah, yeah.
Right. So okay, now it seems like this can iterate as well, right? So maybe you know that you know, but you don't know that you know that you know. Does that create any complications at all?
I mean, I think it sometimes can put us in kind of uneasy positions because it seems that if you know something, that then you can assert it. I can if I know that this something is red, I can tell other people that it's red, and then if they ask me, well, do you know that it's red? Then maybe I shouldn't. If I don't know that I know, then I shouldn't say that I know that it's red because I don't know that. And so we could be put into awkward positions where we can say things because we know them, but then when we're challenged on them, it's hard for us to assert our credentials to say them because we don't know that we were in a position, even though we were in a position to say it. And so that's a kind of awkward position to be in. But I think it would be crazy to make it a constraint on philosophy to say that people can never be in awkward positions.
That's fair. I want to go back to the question about meaning sort of being determined by use.
Yeah.
Because here, I think really everything that you've described so far, I find more or less convincing. And I think when you think about it more, it makes the epistemicist option seem less counterintuitive than it does at first. Here's where I still struggle with it. It's with the sorites based on indiscriminate appearances. So, imagine a kind of, a patch of color, right? A continuous, I don't know, between red and yellow or whatever it may be. And between any two adjacent patches, the color is actually indistinguishable to the eye. You can't tell any difference whatsoever. Now here, again, your solution is going to imply that there is a cutoff. There's a moment where it goes between, let's say, red and orange or whatever you like. Now, and I want to use, to avoid any problems about what color really is, I'm going to use the predicate appears red and appears orange instead of red and orange so that we can sort of bypass that. There's going to be an exact cutoff between appears red and appears orange. And the two, the two patches at either side of that cutoff will actually be indistinguishable to the eye.
Yeah.
And so it seems that there's a cutoff determined by the meaning of this word, let's say appears red, that is, that cuts across somewhere where the appearance is actually identical. And I suppose the reason that this seems hard for me to accept or very counterintuitive is that the sort of semantic meaning of appears red has to do with appearance. And so if the two cases are indistinguishable with regard to appearance, then how can it be that the meaning is different?
Yeah. So here we have to get quite subtle, I think, about the epistemology of appearances, about how much we can know about appearances. And I think you're absolutely right that if two things have exactly the same appearance, then one of them appears red if and only if the other appears red. But what we have to distinguish between is, on the one side, appearance of sameness, and on the other side, sameness of appearance. And let me explain how that's relevant. So if you have two shades which are indistinguishable to the naked eye, then typically we have the appearance of sameness, in the sense that to us they appear to be the same. But appearance of sameness doesn't automatically imply sameness of appearance. So although they appear to be the same, in fact, there are subtle differences between the way that they appear. One of them appears in a way in which the other one doesn't, even though they do appear to be the same. And so that although we have appearance of sameness, we don't have sameness of appearance. And it's only sameness of appearance that guarantees that if one of them appears red, then the other appears red as well. And I think the underlying moral of this is that even appearances are to some extent elusive, that we're not godlike in our knowledge, even of the way things appear to us, that there can be hidden features of appearances themselves. And in particular, there can be differences between appearances to us, which we can't detect. And because we can't detect them, these things they appear to be the same, but in fact they're not the same, even in appearance.
Yeah, that makes sense. There's one potential issue that I see with it, and that is, let's stick with this color example. If there are presumably limitations to how much our eyes can actually discriminate.
Yes.
Right. So even though there may be a difference in appearance that we're not aware of, that actually things appear the same to us, but in fact the appearance is slightly different, maybe we can break down this sorites to the level at which it must be the case that there is actual sameness of appearance, because the difference between the two shades is minute enough that our eyes don't actually have the sort of machinery to discriminate at that level of detail.
Yeah. Well, so however small these differences are, enough of them can add up to a big difference, and that means that something different will have to happen between some of these neighboring pairs. Otherwise, we would just end up with the same appearance at the beginning as we had at the end as we had at the beginning. But I think what on the kind of model that you have in mind, what we're going to get is that with some of these neighboring pairs, there is there's no difference. Let's suppose that at the physical level between the neighboring pairs, and so the appearance really is the same. And so there will be some pairs where there's genuine sameness of appearance, and therefore if one of them appears red, the other appears red as well. But there will also be some neighboring pairs where there is the physical difference is just enough to trigger, if you like, a psychological difference, and in those cases there will not be sameness of appearance, even though there still is appearance of sameness. And so all we need to avoid the sorites paradox is that there are some cases where there's appearance of sameness without sameness of appearance. It doesn't have to be that every single one is a case where there's no sameness of appearance.
So let me see if I understand this. Assuming, kind of, stipulating that the difference between the shades in the sorites is, is positive, right? There is a small difference that you can measure in terms of, wavelength or what have you, but small enough that typically our eyes, can't discriminate between that level of detail. You're saying that it will still be the case in some of those patches that the eye will be able to discriminate. Does that mean that there are kind of like that even if we're at this level of detail, there must then be certain sort of thresholds that the I will kind of cross.
Yes, I mean, of course, where the thresholds come might not be the same, if you run through the series again. So it's not that, as it were, that these are like kind of hidden boundaries, which automatically are going to make a big difference every time. Because this could be, in fact, it's likely to be some more probabilistic process. But the idea is that there might be a little bit of randomness, which varies where these, if you like, where the trigger points come. But there just have to be these trigger points on, basically on logical grounds, because otherwise we'd have the same appearance all the way through. So there have to be places where the appearance changes, but it doesn't have to change at every single point. And it might not change at the same point the next time you ran through the same series of samples.
Right. Okay. So we've so far been working with a sort of theory of meaning in which it's, determined by use in some way, along with certain other factors. Now, what if I wanted to stipulate a kind of a vague definition, let's say? So I want to make up my own word, and so it's not really given by use. I'm going to say what it means, and I'm going to give it a vague definition. Is that something, how would that possibility sort of play into how we deal with the sorites paradox?
Well, I think, as I think Humpty Dumpty said, he claimed that that it's a question of who would be master with words, but we can't always make words do just whatever we like by any old stipulation. So, for example, suppose that I want to, I say I'm going to introduce a new word into the English language, and this word is glunk. And suppose I say, so all I'm going to tell you about glunk is it's meaningful, but I don't tell you anything else at all. Now, I think most people would say at that point, but my stipulation has failed, because I said it was going to be meaningful, but since I've said so little, it just isn't meaningful, and so my stipulation went wrong. And I think you can have much less obvious cases of that. So, for example, take the rules of some sport. So that, supposing you can think of the rule book for a sport as a kind of definition of what counts as scoring a goal or whatever it is, or gaining a point in the sport. And suppose we took some very commonly played game, like football or tennis or whatever, and supposing when we examined the rule book very, very carefully, we found that there was an inconsistency in the rules, some tiny little inconsistency. That wouldn't mean that that there was no such thing as scoring a point in tennis or anything like that. It would just mean that there was some kind of slight mismatch between the actual definition and the meaning that this had acquired, because the definition in a case like that would not really determine anything unambiguously, because it would just be inconsistent if you tried to work out its implications. But still the words would have acquired some meaning, and I think, but the meaning would not be exactly what had been stipulated for it. So that if you try to just by definition to say you're going to introduce a word into English which is going to behave in a non sort of binary way, which is good. The fact that you say that that's what you're going to do doesn't mean that is actually what's going to happen. And So that what happens will, to some extent, not simply depend on what you say, but on how people take this definition, and so we are not completely masters of our language. I mean, we can't just make words do whatever we like, and so even if you tried, I mean, to put it crudely, if you tried to define a word so that it violated the laws of logic, that is no more going to work than if you try to define a word so that it defies the laws of physics.
Yeah, that makes sense. Now, this actually reminds me. So, one more thing I want to ask you. It kind of goes back to the idea of what does meaning really mean. We talked about it supervening on use and there being all of these different factors. Now, one thing that kind of occurs to me is that the actual process that we discussed as determining the meaning of a word, and thereby also determining its cutoff point, in order for it to determine a precise cutoff point, then presumably what constitutes as that process of determining a meaning is a precise process. That we may not know exactly what all the factors are, but there is a fact as to what are exactly the factors that go into determining a meaning, and what factors don't go into determining a meaning.
Yes.
That in itself seems counterintuitive. That is to say that there is a fact about what goes into the determination of a meaning and what doesn't, that we just don't know about, but is actually the fact about how meaning formation works.
Well, but I think there are two things there. I mean, there are two aspects. I mean, one is what the input to this determination is, which is all the facts that are relevant. And I think there's no enormous mystery about that in general terms. I mean, we know that for example, every use of the word red is in principle relevant to what it means, and also the situations in which it's used, the wavelength of light being reflected, and everything else. And of course, we never know all of these facts, but we have a reasonable idea of what type of facts they are. I think so. One aspect is our ignorance of all these details, but I think one thing is pretty clear, is that our ignorance is not just a matter of ignorance of all these detailed facts. It's also ignorance of, if you like, what goes on inside the black box, which takes you from the input of all these facts that determine meaning to the output of the meaning itself, with the boundary that it draws, for example, for red or for heap or whatever it is, and that inside that black box that transforms the input into the output, there's some unbelievably complex function of meaning determination, and we're also ignorant of how that function works. So even if we knew exactly what was going into the black box, that would not by itself enable us to predict what would come out of the black box, because we don't know what's going on inside the black box, and that's because we don't have a perfect understanding of this process of meaning determination, and and we don't really we don't understand it very well, even in ways which don't have to do with vagueness. Even in the simplest cases, for example, if you take mathematical terms like plus and minus and so on, for our purposes, we can treat them as perfectly precise, but we still don't really understand how all the ways in which people use the words plus and minus determine the meaning of the words plus and minus. the philosopher Saul Kripke used this example to pointed out that, I mean, the meaning of the word plus is something that determines addition for any pair of numbers, and there are infinitely many pairs of numbers, and so a meaning is determined for x plus y, even when numbers x and y are numbers that nobody has ever thought of and nobody ever will think of in the entire history of the universe, but still a value for their sum is determined. And we have a very rough idea of how that happens, but not at all an exact idea of that process. And so that process is, as it were, what's going on inside the black box that takes us from the determining facts to the meaning. And so there are really, it's both ignorance of the input and ignorance of what happens in the black box that makes us, it prevents us from just working out what the meaning or boundary is going to be, in terms of input plus black box.
Yeah, and I think the thing to take away from that is that, meaning is not this sort of thing that we sort of stipulate and then investigate as a kind of natural phenomenon that we really, in many respects, don't understand.
Yeah, I mean, and I think people find that, initially they find that a bit puzzling because they think, well, surely we make these meanings, so we ought to know all about them. But, I mean, in some sense, I've been involved in making 3 children, but the fact that I made my 3 children doesn't mean that I know all their secrets.
Yeah. And also, it's very important to note that we may all be involved in the making of these meanings, but no specific one of us sort of decidedly determines it.
Yeah.
Okay, I have just one final question for you. What do you personally consider the strongest objection to epistemicism?
Well, so the objections that I find most challenging are not the objections from people who just find epistemicism totally implausible and don't take it seriously. The objections that I really find intriguing are ones from philosophers who are pretty sympathetic to epistemicism. People like, for example, John Hawthorne and Ofra Magador and others, who've thought through the consequences of epistemicism, and they've realized that there are some problematic cases where the kind of simple model of how vagueness works that I gave in my book is not fully adequate. And I think what these really have to do with is the fact that in simple cases we can make a fairly easy distinction between changes in the world and changes in language. So, for example, with the word heap, on one side there is change in the world, which is when you actually add or subtract grains from the heap. But you don't change the meaning of the word heap. And on the other side, there's changes in the meaning of the word heap, where you don't actually add or subtract anything from the heap. The physical thing there itself stays the same, but we change the meaning. And the kind of account that I gave of what's going on in cases of vagueness used that distinction between changes in the world and changes in meaning, and I think that was quite adequate for those simple cases. But that distinction between meaning or language and the world, it's one that in the end it can't be fully adequate, because after all, language itself is part of the world, and we can have examples where the fact that it's part of the world means that we can't draw this nice line between changes in the world and changes in meaning or changes in language, because they're actually interacting with each other in a kind of constitutive way. And so for cases of that kind, we're definitely going to need a more complex story than the one that I gave for relatively simple cases in vagueness. And so I think there are challenges to develop the epistemicist theory further to deal with these tricky cases. And I consider I'm much more interested in those than in just people who think the whole approach is wrong-headed. I mean, these are not challenges which make me think that the approach is fundamentally mistaken, but they're ones which make me realize how much more work there is to do to get a fully satisfactory theory. Maybe we'll never get a fully satisfactory theory, but I hope we can get better and better theories that are refine and generalize more and more on what we've already got.
Gotcha. Well, Tim, thank you very much for joining me.
Well, thank you for your good questions.
Yeah, it's a fantastic conversation. Thanks a lot. And that concludes today's episode of Who Shapes the Barber? Next week, I speak with economist Brian Kaplan about his new book, The Case Against Education. Again, I'm William Nava. You can check out other episodes, as well as my other philosophical and artistic work at williamnava.com. And if you'd like to subscribe to this podcast, go to williamnava.podbean.com. Thank you so much for listening.